All right, so part 2, lesson or example number 3. So let's jump over to this example. So it says, in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum is 5 minutes. Write an absolute value equation that represents the minimum and the maximum length. So we're almost going backwards and setting up an equation and not just solving, because those are the solutions. You can go either 4 minutes or 5 minutes, right? So you have the little window. So to set this up, you always have x minus. It's always minus. But then what do we put here? So back here, we're going to put the average of the two numbers. So average of the two numbers. And then that will give us the distance from the midpoint of how far you can move to the right and to the left. So distance from midpoint. So let's see what that is. So I'm going to set this up, right? It's always x minus. So we have the two numbers. We have 4 and 5. We have to find the average. So we're going to say 4 plus 5, right? There's two numbers, so we're going to divide it by 2. So we end up with 4.5. Awesome. And that's actually what goes inside of the absolute values. Okay? And now the distance from the midpoint. So you will always grab the bigger number, whatever is given to you. So in this case is 5. And then you're going to subtract your average, 4.5. And what do we get? 0.5? We get our 0.5. So that's it. But now let's see if this really is the correct equation. So if I were to solve it, my goal is that we're going to get those two solutions. So let's check. So if I were to drop the absolute value, x minus 4.5 equals 0.5, or x minus 4.5 equals negative, right, 0.5. So let's solve and see if we get the two solutions. So I'm going to add 4.5 to both sides. X equals 5. Perfect. That's exactly the maximum, right? And if you add 4.5, we end up x being 4. So yes, this was the correct equation because we did get the solutions, the minimum and the maximum. So your job is just to set the equation up. Okay, we have example number 4. So another story problem. In my opinion, I think that's the hardest part of the lesson. Like, think it through. So for a poetry contest, the maximum length of a poem is 16 lines, the minimum, and the maximum is 32. Write an absolute value equation that represents the minimum and the maximum length. So I want you to try to set it up on your own. You can look at my example. And then we're going to see if you guys have the same equation. So try to do it on your own. Remember, it's always x minus. So you guys try it, and I will do it kind of quietly. What did you guys get? Did you get the same equation? Yes? Awesome. So if we don't have to solve it, but if you were to draw it on a number line, your solution, 24. So if you go 8 units to the right, what do you get? 32, right? And if you go the 8 units to the left, you will get your 16. So perfect. This is our solution. Good job. Easy? I hope it is. All right, and next here we have another core concept. So solving equation with two absolute values on both sides of the equal sign. So if you have absolute value of ax plus b, and you have this set equal another absolute value of whatever it is, you're going to keep the first one the way it is. You're just going to drop the parentheses. But for the second one, you're going to add that negative to your right side. Okay, so let's do a few of those problems, and that will kind of become a habit for you guys. So absolute value, absolute value. So we're going to just drop the first one, right, the way it is. I just dropped the absolute value parentheses, and then or, so drop the first one, and then you're going to add that negative to whatever that was, which is just x. And I have parentheses because later on you guys will have little expressions in there. So let's solve it. So you have 3x minus 4 equals x. I am going to subtract 3x on both sides. So I end up with negative 4 equals negative 2x. Divide by negative 2. What's our x? 2? Awesome. Now if you want to rewrite, you're more than welcome to. It's the same thing. Now this one, so 3x minus 4 equals just negative x. I'm going to move this x to the other side just because it seems like it's a little easier. Negative 4 equals negative 4x. Divide by negative 4 because we're multiplying by negative 4. And what's our x? Did we get 1? Yay! Not bad at all, huh? Easy? If you're looking at B, both of them are the answers. Yep, 2 and 1. So x is 2 and 1. 2 answers. Both of them are the correct answers. Just remember, you moved how many units, and you end up with 1, and then you will end up on 2 on the number line. So you end up at 1, and you end up at 2. Oops, I should go this way. 1. Those are your solutions, the 2 points. Okay, how about this one? So this one has a number in front of it. But yet again, there's nothing we can simplify or do. You do not want to distribute that yet or do anything with it. You want to just set them up, right, and drop the parentheses off. So the first one, you're going to copy your 4x minus 10 equals, and now we have 2. But to drop the parentheses, absolute value, you're going to have the regular parentheses. So we have 3x plus 1. Now for the second one, so you drop the first one, but you're going to add that negative, right? And you have 2, same thing, in parentheses, 3x plus 1. And now you're going to distribute. So we have 4x minus 10 equal, and distribute your 2, remember, to both of the numbers. So 2 times 3, which is 6x, 2 times 1, which is 2. And now we get to simplify. You can move 10 first, or whichever one you want. I actually like moving this first, but it's just a preference. So we end up with negative 2x minus 10. And that equals 2. Move your 2 to the other side. Oops, sorry. we end up with 2x equals 12. So divide by negative 2, x equals negative 6. So that's the first solution. Remember, you have two of them most of the time. And for the second one, you're going to distribute this time actually negative 2. So we have 4x minus 10 equals negative 2 times 3, which is negative 6. X. Negative 2 times 1, which is negative 2. I will move my 6x to the other side, so add 6 on both sides. You end up with 10x minus 10 equals negative 2. Move your 10 to the other side. So 10x equals 8. And divide by 10. X equals, I'm going to just simplify it by 2, so it's 4 over 5. So here is my second solution. 4 over 5. So two solutions. Think of a number line. Okay. All right, moving on. So to make sure, let me know if we're going too fast, we can slow down, okay? Or seems like you guys are ready, right? All right. So our last 3 examples. So actually this one is something that you guys will do on your own. It's very similar to the one we have just done. Remember, the right side is the side that you add the negative, and then you keep it positive the way it was. So think about this one. Oop. See how you would set this up. How do you drop the parentheses? You guys try it, and I will do it on the board. Any pencil? When you set your equation, you can look at the board and see if this is how you set yours up as well. So you don't have to do all of this incorrectly. So the next one, if you see that check your solution, you should be a little suspicious. Like, okay, it's just kind of weird. Why do they want me to check the solution? And here is the reason why. So let's just solve it the way we are, and then let's check and see if there's something that is going to happen. So just how you normally set this up, you would just drop the absolute value for the left side equals 4x, or you can have the 2x plus 12 equals, now that's when you add that negative, right? Negative 4x. So if we solve it, I am going to move my 2x to the other side just because then we have all the x's like there. So 12 equals 2x. Divide by 2, x equals 6. So, okay, so here's my one answer. And then let's try the second one. So I'm going to move my 2x to the other side. We end up with 12 equals negative 6x. Divided by negative 6, and x equals negative 2. Okay, so well, let's just check. The way you check, you always want to plug it back into the original equation, not anywhere but original equation. So to check, I'm going to have the absolute value, and now 2, we said x is 6, right? Plus 12 plus absolute value, and then we have 4 times 6. Okay, well, let's simplify it. So we have absolute value, 2 times 6 is 12, plus 12, and then 4 times 6 is 12. So absolute value of 12 plus 12, which is 24, equals, let's say 12, no, let's say 12, 24, 24. So if you drop absolute value, it really is 24 equals 24. So that one checks. So we know this is right. Now the second one. So absolute value 2, but now our x is negative 2. Plus 12 equals 4 times negative 2. All right, so let's simplify it. So 2 times negative 2 is negative 4, plus 12. 4 times negative 2 is negative 8. If we simplify it, 8 equals, absolute value of negative 8 equals negative 8. So if I take this from absolute value, that's actually 8. And you can see that 8 does not equal negative 8. So this solution is actually not part of the solution. We call it extraneous solution. So extraneous solutions. So this one only have really just x being 6 our solution. So when you see that to check your solution, you expect something that one of them will not actually work. Okay, and last but not least, let's do our number 6. And I'll use black because I think it's easier to see, or green. So absolute value equals absolute value, same thing. X plus 5 equals x plus 11. Or x plus 5 equals, now remember, negative, and then you have parentheses, x plus 11. So if you simplify it, so I'm going to move this x to the other side. So it happens, x's cancel, right? So we have 5 equals 11. Is that a true statement? No, right? So that's actually no solution for this one, but we might have an answer on this one, you never know. So we're going to take that negative first and distribute and see what's going to happen. So it's x plus 5 equals negative x minus 11. I'll move my 5 to the other side. So we have x equals negative x minus 16. Add your x. So now we have 2 x's, they didn't cancel. Divided by 2, and your x is negative 8. That's your solution. All right, so let's practice. So on the board,